In this video, I'm going to show you how to convert a decimal number to a binary number. So, just to start off, a decimal number is just a base 10 number, and a binary number is a base 2 number. And let's do an example. So here I have a decimal number of 336. This 336 number is a base 10 number, and I need to convert it to base 2. So to convert it to base 2, I'm going to divide 336 by 2. And what I'm really interested in is the remainder. The remainder is going to tell me the binary number. So 336 divided by 2 will give me 168. With a remainder of 0. 168 divided by 2 will give me 84 with a remainder of 0. 84 divided by 2 gives me 42 with a remainder of 0. And you're going to want to divide until you can't divide anymore. So 42 divided by 2 gives me 21 with a remainder of 0. 21 divided by 2 will give me 10 with a remainder of 1. 10 divided by 2 will give me 5 with a remainder of 0. And 5 divided by 2 will give me 2 with a remainder of 1. And 2 divided by 2, I cannot write. I'll just fix this whole thing. Two divided by 2 will give me 1 with a remainder of 0. And 1 divided by 2 is 0, so I have a remainder of 1. And like I said earlier, what I'm really interested in is the remainder column over here. So now I'm going to rewrite it, and I'm actually going to rewrite it going from bottom to top. So I'm going to start out with this 1 right here, then move up to the 0, the 1, and so on. And I'm just going to write it out. So my first number is 1, 0, 1, 0, 1. And I just got that from right here, 1, 0, 1, 0, 1. And 0, 0, 0, 0. So this number right here, is actually my binary number. And I'm going to write it in parentheses and put a little 2 here. This is the correct answer. So 101010000, which is a base 2 number, is my final answer. And this is my binary number. So we converted 336 in decimal to 101010000 in binary. I hope you found this video helpful. If you did, check out our website at engineeringtutor.org.
Hello there! In this tutorial we are going to learn a simple conversion trick from decimal to binary. Decimal represents the numbers you use on a daily basis, 0 to 9. So the base of decimal is 10, because we have 10 options to represent one digit, which is also called a bit. Binary numbers are only ones and zeros. So the base of binary is 2, because we only have 2 options to represent one bit. I've created the following table so it will be easier to understand where the numbers came from. To calculate the decimal value of any base, not just binary, you take the base and power it by 0, then 1, 2, until 8, for example, and we'll soon see why I chose 8 and not by 9 and 10 and so on. So here are the results of the table above, reminding you that a number powered by 0 always results as 1. I could have added more bits, and again, we'll see soon why I didn't add more bits to the left here. So what's the highest decimal number that can be represented with 9 bits? We got here 9 bits. Well, it's the summation of all the numbers you see in this table, which is 511. If I want to convert a number that is higher than 511, I will need to add more bits to the left side of the table. So I will need to do 2 power 9, 2 power 10, it depends on the number. Let's get to business. Let's remove this table and this number, and in practice we will only write down this table, which is 1, 2, 4, 8 until 256, or any other number that you want, depends on the number we want to convert. Let's take, for example, the number 292. That's our target. I'm adding a blank table. Here will be our converted binary number. And we start with a 0. And we move from left to right until the finish line. And we will reach the finish line with 292 with our target. And when we arrive here, we'll also have our binary number written up in this empty table. So let's start. We ask, does 0 plus 256 fit in 292? The answer is yes. So we add them up and we write down 1 in here. Moving on to 128. Does 256 plus 128 fit in 292? No. So we don't add them up. We just put 0 over here. Moving on to 64. Does 256 plus 64 fit in 292? No, it's not, so we put a 0 over here. Moving on to 32. Does 256 plus 32 fit in 292? Yes, it is. It's 288. So we sum them up and we put 1 over here. Moving on to 16. 288 plus 16 does not fit in 292, so we put a 0. Going to 8, same goes here. 288 plus 8 does not fit in 292, so we put a 0. Moving on to 4. 288 plus 4 fits in 292. That's a bullseye, so we sum them up, we put 1 over here, and then we know that the rest of the numbers over here must be 0, because we don't need to sum them also, because we got the number. So moving on to 2, it's gonna be 0. Moving on to 1, it's gonna be 0. That's it. We're done. 292 in binary is 100100100. This is how you write the number in binary. And of course, finish.